This is going to be chapter 7 on memory. Once again, I am at home and my cat is very talkative today, so hopefully she'll be able to stay quiet for the majority of this lecture. So first off, we're going to talk a little about studying memory and how that works. Then we're going to talk about encoding, so building memories, then memory storage, retrieval, how we get information out of our memory storage. Then we'll talk about forgetting, memory construction errors, and steps we can take to improve our memory. So first off is studying memory. First we're going to go over the important definitions of studying memory, and then we're going to get into some of the different processing models of studying memory. So memory is the persistence of learning over time through the encoding, storage, and retrieval of information. We talk a lot about memory, and memory is very closely linked to learning, which was chapter 6, and so we're going to rely a little bit on that as we go through this. So psychologists have created memory models that they are imperfect, but they are a good way of thinking about memory and a good way to begin to understand how our memory works. So the model we're going to talk about today is the information processing model. And part of that model is this 3-step approach: encoding, storage, and retrieval. And we're going to break those down even more as we go through this lecture. Briefly, encoding is the process of getting information out or getting information into the memory system. So getting information to our brain, that's encoding. Storage is the process of retaining encoded information over time. So it's keeping the information that we've encoded. And retrieval is the process of getting information out of memory storage. So those are the 3 basic steps, and we're going to go a lot more in depth into each of these. Before we can do that, however, we have to talk more about the information processing model. The information processing model has 4 different types of memory. There's sensory memory, short-term memory, long-term memory, and working memory. The first 3 have been around for a while. They were developed by Atkinson and Shiffrin. However, more modern psychologists have added working memory to this list of the information processing model. So sensory memory is the immediate, very brief recording of sensory information in the memory system. So it's very fleeting. It doesn't stay for very long. It's the to be remembered information. So that is sensory memory. It's the immediate memory. It's brief, and it's to be remembered. It has not entered the processing. It has not entered the memory storage or even been encoded so that it can be stored. The next is short-term memory. This is activated memory that holds a few items briefly before the information is stored or forgotten. So this is the memory that happens after sensory memory. So sensory memory, then encoding takes place and the memory is put into your short-term memory. Your short-term memory holds a few items at a time. It cannot hold an unlimited number of items. And then after it has been in your short-term memory, it is either stored in long-term memory storage or it is forgotten. Long-term memory is the relatively permanent and limitless storehouse of the memory system. It includes knowledge, skills, and experiences. This is where memories are stored for the long term. And once it's there, it can be retrieved later on. Once it is retrieved, it goes back into working memory. Working memory is kind of in the same area as short-term memory. It's a newer understanding of short-term memory that adds the conscious active processing of incoming sensory information and of information retrieved from long-term memory. So the long-term memory storage will send like a memory back to the short-term working memory, and that's where we are able to consciously process it. We cannot be consciously processing it while it is in memory storage. If you look on page 191, there is a figure 7.1, which is a modified 3-stage processing model of memory, and it kind of shows us very clearly where the path that memories can take. So yeah, those are the 4 things that we kind of need to be aware of as we go through understanding the encoding, the storage, and the retrieval of memories and information. So the next section is building memories, which is also called encoding. So there we have a 2-track system in our mind. We've talked about this a lot. You'll continue to learn about it through the rest of this course series. When it comes to memories, there are implicit memories and there are explicit memories, and with that, it has the two-track processing. So the automatic processing and the effortful processing. So implicit memories can also be called non-declarative memories. This is retention of learned skills or classically conditioned associations without conscious awareness. So implicit memories are learned skills, things that we are classically conditioned to do, and there is no conscious awareness to implicit memories. Automatic processing is the unconscious encoding of everyday information, such as space, time, and frequency, and of well-learned information, such as word meaning. Implicit memories are formed through automatic processing, and they bypass the conscious encoding process. So if you look at that figure on page 191, you'll see the automatic processing skips over the working and short-term memory and goes straight into the long-term memory storage. The second track of this is the explicit memories, which can also be called declarative memories. And this is retention of facts and personal events that you can consciously retrieve. So they are facts and experiences we consciously know and declare. That's why can also be called declarative. And we encode explicit memories through effortful processing. Effortful processing is encoding that requires attention and conscious effort on our parts. So that is in figure 7.1, the longer track where things go from our sensory memory, they're encoded to the working and short-term memory, and they're encoded again into the long-term memory storage. This is explicit memories and effortful processing. So how does automatic processing and implicit memories work? Implicit memories include automatic skills and classically conditioned associations, like we talked about. And we automatically process information about space, time, and frequency. While studying, you often encode the place where certain materials appear. Later, when you want to retrieve the information, you may visualize its location. So this is kind of like you're not consciously processing where you're studying information, but you'll be able to remember where you studied the information. Time is what the example the book gives is while you are going about your day, your brain is working behind the scenes, jotting down the sequence of your day's events. Later, if you've realized you've left your phone somewhere, you can call up that sequence and retrace your steps. This is something that's not automatic, or that is automatically happening. We're not having to consciously think of this as we go through our day. We're not going, okay, I am currently eating breakfast, and then later while you're getting ready for the day, you're not saying, I apologize for my cat. You're not saying, okay, after I ate breakfast, I got ready for the day. After I ate breakfast and after I got ready for the day, I went to my car to go to work. Those are not things that you are consciously doing. It happens automatically. And frequency is when your behind the scenes mind also keeps track of how often things have happened, thus enabling to realize this is the third time I've run into her today. So you're not consciously processing or counting how many times you run into someone throughout the day, but your automatic processing is doing this, is noticing that. So automatic processing is just one path of our 2-track mind. The other is effortful processing. And this division of labor, this division of processing, illustrates parallel processing, which is processing many aspects of a stimulus or problem at once. And we've talked a lot about parallel processing and all the different ways we've seen that. We talked about it in chapter 2 and chapter 5, and have been talking about it throughout the term. So we're not going to go too much into that. The next is effortful processing and explicit memories. So there is a lot to consider when we are talking about effortful processing. So effortful processing, when you're reading a book or a text or anything, this is automatic processing at this point. However, learning to read was not automatic. We first had to work hard to pick out letters and connect them to certain sounds, but with experience and practice, it became automatic. An example that I can give is when I first started teaching at the elementary school. I was teaching in small groups, and the students would be sitting in front of me, and they'd have their workbook or the book that we were reading in front of them, and I would be reading upside down because I would not have a book of my own, or I would be reading what they wrote, and stuff like that. And this was not automatic for me at first. I had to really think about what I was doing, but as I taught longer, it became automatic, and now I can read upside down with very little difficulty. So, sensory memory is the first stage in forming explicit memory. The possibility of a memory enters by way of the senses, but sensory memory is very quick, it's fleeting. So, yes, sensory memory is the first stage. However, if sensory memory does not make it to the next stage, it will not be remembered long term. A lot can be forgotten as this happens. So again, as a reminder, short-term memory is activated memory that holds a few items briefly, such as digits of a phone number while calling, before the information is stored or forgotten. This is the first stage of effortful processing, is this short-term memory. So when it comes to short-term memory capacity, it is limited. We can only briefly retain a limited amount of information. So when we look at, when we think about short-term memory, we might be asking, what is the limit to that memory capacity? And a memory researcher proposed that we can store about 7 bits of information, give or take 2 in short-term memory. If you think about a lot of things, they come in 7s throughout the world. There's the 7 wonders of the world, the 7 seas, the 7 deadly sins, 7 colors of the rainbow, 7 musical scale notes, 7 days of the week. This is referred to magical 7s, and it's just an interesting thing that this has happened, and the book calls it Psychology's Contribution to the List of the Magical 7. Other researchers have confirmed that we can recall about 7 bits of information if nothing distracts us, but the number varies by task. We tend to remember about 6 letters and only 5 words, and other examples of that. Working memory capacity varies a little bit from short-term memory capacity. This is often dependent on age and other factors. Young adults have a greater working memory capacity than children and older adults. But the key to all of this is the more sensory information that is coming in and entering your short-term memory, the harder it will be to remember the information. So everyone does better and is more efficient, does more efficient work when focused without distractions, doing one task at a time. So this is an important thing to remember when you're studying or writing papers and stuff like that. So part of effortful processing is that our minds um, have processing strategies, and we've learned that in order to form lasting explicit memories of a fact or experience, it helps to focus our attention and make a conscious effort to remember. But that the working memory has limited space. And so in order to do this, our brains can use different tools, different strategies. The first is chunking. Chunking is organizing items into familiar, manageable units, and it often occurs automatically. We do this automatically, and it's something that we can both consciously do. We can choose to chunk information into familiar and manageable units. However, some things do happen automatically. When counting a number of items, you might group them into sets of 2 or 5 because it is easier to it's more manageable that way, and that sort of thing. The other strategy is mnemonics, and these are memory aids, especially techniques that use vivid imagery and organizational devices. So this, some examples of this are acronyms, rhymes, songs, stuff like that. So these are ways that you could, that you consciously put these memories, this information into mnemonics, and this is in order to help you remember. An example of this would be Roy G. Biv, to help you remember the order of the colors of the rainbow. There is also, I'm trying to think of other ones, and I'm just not having much luck right now. I remember when I was in middle school, we had to memorize this formula for math, and my teacher put it to all around the mulberry bush, and I can remember that that formula to this day, even though I don't use it, and it's because he put it in a mnemonic, which made it easier for me to remember. Another part of effortful processing and explicit memory is space study and self-assessment. So these are ways that you can help yourself to remember things. I apologize for my cat. She's being obnoxious today. So spacing effect is disturbed practice. This is the tendency for disturbed study or practice to yield better long-term retention than is achieved through mass study or practice. So basically what this is saying is that it is more effective to space out your studying instead of trying to yield the long-term retention, to be able to remember things for longer periods of time than it is to like cram the night before. So it is a better use of your time to space out your studying for a final than it would be to cram it all the night before. The other is called testing effect. It is also called retrieval practice effect or test enhanced learning. And this is enhanced memory after retrieving rather than simply rereading the information. So in terms of like being a student, the testing effect would say that instead of simply rereading your notes or rereading the text, it would be it would better enhance your memory if you were to quiz yourself, find practice tests, that sort of thing, because that will better your memory, and make it last more long term. The last point in effortful processing and explicit memories is making new information meaningful. So spaced practice helps, testing effect helps, chunking and mnemonics helps, but if new information is neither meaningful nor related to your experience, you will have trouble processing it. And so if you're able to make things meaningful to you, you are better able to remember it. So some of the ways that you can do this is taking what you're learning and seeing if you can apply it to specific situations in your life, or people in your life, or create examples in your own life. Other ways that this can help is if you, or like when I teach, I try and give as many examples from my personal experience as possible, because that's how I am able to remember. And so since some people can't personally relate to the information, if I give them an example that seems more realistic and abstract, it might help them remember. So when you make the new information meaningful, you are better able to retain it and remember it in the future. So studies have found that people most easily remember personally relevant information. And so if we make what we're learning relevant to us, we will remember it more. The point to all of this is you can profit from taking time to find personal meaning in what you are studying. So all of these are important tips for you to use as you go through schooling, as you work on studying and memory, stuff like that. I wish this was more towards the beginning of the term, but we're covering it now, so hopefully that can help. The next thing we're going to talk about is memory storage. So, how do we retain information in the brain? It depends on the memory. Is it the explicit memory system or the implicit memory system? So first we're going to talk about the explicit memory system. This involves the hippocampus and the frontal lobes, and we know that conscious memories, explicit memories, are either semantic or episodic. So semantic memories are explicit memory of facts and general knowledge. So this is the ability to remember. Semantic memory is remembering the facts for a test, remembering directions, that sort of thing. Episodic memory is explicit memory of personally experienced events. So this would be remembering your high school graduation, remembering a concert that you went to, anything like that. So those are the two types of explicit memories. So, epi- so new explicit memories, both semantic and episodic, um, are laid down via the hippocampus. This is the neural center located in the limbic system, and it helps process the explicit conscious memories for storage. Um, the the book described the hippocampus as our save button. So in order to remember our semantic and episodic memories, we have to we have to hit the save button. It has to go through our hippocampus. So part of the storage process and retaining information for explicit memories is memory consolidation. This is the neural storage of a long-term memory. So as we are developing our memories, as our memories are being encoded and processed, they're consolidating in order to be put into the long-term memory storage. I apologize if I'm a little out of it, guys. It's been a day, so I'm trying to get this up for you because it tends to take a while to upload. So I want to keep moving along. Implicit memories go through the cerebellum and the basal ganglia. This is where your memories of physical skills like walking, cooking, dressing, motor movements, all of these things are stored in your cerebellum and your basal ganglia. I am not too worried about you knowing those. So do with that what you will. It's probably not on the final. So the amygdala, emotions and memory. We know that the amygdala is kind of our, well, it's not kind of, it's one of the really important parts of processing emotions, and emotions are very strongly linked to memory. So stress hormones can focus our memory, and they provoke the amygdala to boost activity in the brain's memory forming center. So these emotions often are emotions are very strongly linked to memory, and that is because of the connection with the amygdala and those the emotions that are felt. A flashbulb memory is a clear memory of an emotionally significant moment or event. It's as if the brain says, you got to capture this and capture this exactly. These are caused by emotion-triggered hormonal changes, and it explains why we remember exciting or shocking events more than others. And then also these dramatic experiences remain clear in our memory, in part because we rehearse them more, we think about them more, and we describe them more to others. So that's another reason why these flashbulb memories are so strong. So when we are going through the memory process, the memory storage process, we are experiencing synaptic changes. So, as we are classically conditioned, our synapses begin to fire more frequently and become more effective. And as we talked about in chapter 2, neurons that fire together, wire together, that makes them stronger. So, as we rehearse or as we are classically conditioned, our synapses fire more, and that makes them stronger, which makes our memory stronger. So memories do produce a synaptic change in our brains. So as we learn, our neural networks change to reflect that. And as our synapses become more efficient, so do our neural networks, which means those particular memories will become more relevant. So when this happens, sending neurons will release neurotransmitters more easily, and receiving neurons may grow additional receptor sites. And this increased neural efficiency is called long-term potentiation, LTP, which is an increase in a nerve cell's firing potential after brief and rapid stimulation. LTP is the neural basis for learning and memory. Again, this is not something that I am going to be testing you on. On page 198, figure 7.7 shows a really good diagram of our memory system, our two memory systems. So that would be a good thing to look at. So, retrieving memory. How do we get the information out once it's been in storage? We can do this a few different ways. So the first is so there are different ways that we can measure memory retention. And this is recall, recognition, and relearning. So recall is memory demonstrated by retrieving information learned earlier, as on a fill-in-the-blank test. Recognition is, or let me go back to recall. Recall is being able to retrieve the information out of storage and into our conscious awareness. So we have to go in, find the memory, and then bring it into our conscious awareness. The next is recognition, and this is memory demonstrated by identifying items previously learned, as on a multiple choice test. So it's when you're given a list of things and you have to be able to recognize if they are what you have learned, what you have remembered. And the last is relearning, which is memory demonstrated by time saved when learning material again. So learning something more quickly when you learn it a second time or at a later time. So an example of this is when you review the first weeks of coursework to prepare for your final exam, it will be easier to relearn the material than it was to learn it originally. One of the things that is true about retention is long after you can no longer recall something, you are still able to recognize it. So may not be able to recall or list a number, or most of your high school classmates. I mean, might not be true for you depending on how old you are, but here's a better example. You may not be able to recall a list of your classmates when you were in kindergarten or first grade, but you would be able to recognize their pictures and spot their names in a list of names. So tests of recognition and of time spent relearning demonstrate that we remember more than we can recall. So yes, recalling is a very important part of memory retention. However, we can remember things more than we can recall them. And so that's why people will find multiple choice tests easier than fill in the blank tests, because recognizing something you've already learned is much easier than recalling it. So how are we able to recall this information? We do this through retrieval cues. Retrieval cues are any stimulus, which can be an event, feeling, place, anything like that, linked to a specific memory. So a retrieval cue is something that is like an anchor point for pathways you can follow to access the information. A retrieval cue might be if you're listening to a song that you listen to a lot right after you broke up with a long-term boyfriend, that can be linked to specific memories of that time, and so that would be a retrieval cue. The song would be the retrieval cue. So priming is the activation, often unconsciously, of a particular associations in memory. So this priming process happens without conscious awareness. So an example of this is if you ask in rapid fire questions, what is the color? What color is snow? What color are clouds? What do cows drink? Your friends might answer milk, and that's because you have primed them by talking about white things, white snow, white clouds. And so when you get to what do cows drink, what do we associate with cows that are white? That is white, is milk. So that is an example of how priming works. Context-dependent memories are memories that remembering depends on our environment. Context-dependent memories are things that you remember because they are because of the context you are in. So the example given is when scuba divers listened to a word list in two different settings, either 10 feet underwater or sitting on the beach. They recalled more words when later tested in the same place where they first heard the list. So that is context dependent. They remember it more if they are in the context of where they learned it. By contrast, experiencing something outside the usual setting can be confusing. An example would be like running into a teacher um, in an unusual place. When I was teaching elementary school, it was always very shocking for kids to run into me at the grocery store. And they would recognize me, but they wouldn't necessarily be able to place me because I wasn't in the context of the school. So the encoding specificity principle is the idea that cues and context specific to a particular memory will be most effective in helping us recall it. So it'll be easier for you to recall something if you are in the same context in which you learned it. State-dependent memory is closely related to context-dependent memory. What we learn in one state may be more easily recalled when we are again in that state. So an example of this is when you are in a bad mood, this may trigger other unhappy memories. If you are sad, this may trigger other sad memories. And so this is the tendency to recall events that fit our mood is called mood congruent memory. So the tendency to recall experiences that are consistent with your current good or bad mood. This is state-dependent memory. The last thing for under retrieval cues is the serial position effect. The serial position effect is our tendency to recall best the last and first items in a list. So if you are being given a list of things to remember, you're more likely to remember the first and last and forget the ones in the middle. If you're being introduced to a bunch of coworkers, you're more likely to remember the first person and the first few people and the last few people. When this was being studied, they called it the recency effect and the primary effect. They've combined this into the serial position effect. Where it is within the list can determine how well you will remember it in the future, and usually the things in the middle of the list tend to be what is forgotten. So the next section is going to be forgetting. So forgetting has a lot of different areas. There are a lot of different ways we can forget things. As we process information, we sift through it, we change it, and we lose it. And we actually end up losing most of it. So when we think of forgetting, we have to be able to talk about the different ways that we can forget. And so forgetting in the two-track mind is something that we have to consider. There are two different types. There are two different ways that we can forget in terms of the two-track mind. And this is antegrade amnesia and retrograde amnesia. Antegrade amnesia is an inability to form new memories, and retrograde amnesia is an inability to remember information from our past. So these can have very varying causes. However, it's one of those things that is not really understood, because even with retrograde amnesia, certain things are still someone is still able to do despite the amnesia. Some are still able to read and write, and so how that works is something that We just don't know. So one of the reasons for forgetting could be encoding failure. So much of what we sense, we never notice. And what we fail to encode, we will never remember. So age and so if things, what we are sensing, we have constant sensory input, which we talked about in chapter 5. However, a lot of what we're sensing we don't notice. But there's another process to that, where if we are not encoding what we are noticing, we will not remember it. So one thing that can affect our encoding ability is age. When young adults encode new information, areas of their brain jump into action. In older adults, these areas do still respond, however, they are slower to respond. This encoding lag helps explain age-related memory decline. So we pay conscious attention to only a limited portion of the vast number of sights and sounds bombarding us. However, we do So even though these sights and sounds are constantly bombarding us, we may not be able to accurately or see or recall them because of them not being encoded correctly. So there was a study that only 1 of 85 UCLA students could accurately draw the Apple logo. While they have been exposed to it many times, that has not been encoded in a way that they can remember exactly what it looks like. The next way that we can forget is through storage decay. So even after encoding well, we may later forget it. And this is because of storage decay. So the course of forgetting is rapid at first, but then it does level off over time. So at first we will forget a lot of what we remember, but as time passes, this forgetting levels off. One explanation for this forgetting curve is a gradual fading of the memory trace. So the memory trace is the lasting physical change in the brain as the memory forms. So we talked about how there's physical changes when memory forms, but as that memory is not accessed, those pathways become weaker and begin to disappear, and this is why we can forget it. And that's kind of why they call it memory decay, because those pathways are slowly decaying. So the next thing we're going to talk, or the next way of forgetting, is through retrieval failure. A memory may be out of reach because we do not have enough information to access it. So we might not have enough retrieval cues to be able to follow the pathway to where that memory is. And this is often because of interference. So proactive interference is the forward-acting disruptive effect of older learning on the recall of new information. And retroactive interference is the backward-acting disruptive effect of newer learning on the recall of old information. So proactive interference occurs when an older memory makes it more difficult to remember new information. If you buy a new combination lock, your well-rehearsed old combination may interfere with your retrieval of the new information. So that's proactive. So when older memories make it more difficult to remember the new memories. Retroactive interference occurs when new learning disrupts your memory of older information. If someone sings new words to the tune of an old song, you may have trouble remembering the original. New learning in the hour before we fall asleep suffers less retroactive interference because the chances of disruption are fewer. So old and new information do not always compete. However, they can. And so an example of how they don't compete is like knowing Spanish can help you potentially learn French or Italian faster because of the similarities. So this is retrieval. This is a part of retrieval failure, is the interference that might be preventing you from remembering something, either proactive interference or retroactive interference. There is also motivated forgetting, and this is when someone is motivated to not remember something accurately. So an example is information was encoded properly and is still intact, but it's not retrievable because it would be embarrassing to remember. Sigmund Freud proposed the idea of repression, which is, according to the psychoanalytic theory of Freud, the basic defense mechanism that banishes from consciousness anxiety-arousing thoughts, feelings, and memories. Gotta plug my computer in. So he argued that painful or unacceptable memories are repressed in order to protect ourselves. Increasing numbers of memory researchers think repression is rarely, if ever, occurs. One of these examples is that trauma victims rarely are forgetting their trauma-related experiences. Trauma-related experiences are often flashbulb memories, and so current memory researchers do not believe that repression happens as often as Freud proposed. And so motivated forgetting, while it can happen, it rarely does, according to modern memory researchers. So another way that our memory can be impacted is through memory construction errors. And this can happen in a couple of different ways. The first is reconsolidation, and it is a process in which previously stored memories, when retrieved, are potentially altered before being stored again. So what happens is we have memories in memory storage, and when we remember it, we bring it back into our working memory in order to remember it. But before it can go back to memory storage after the information is no longer needed, we re-encode it. And if we are re-encoding it, we are changing it. And so this is how reconsolidation works. And this is how memories will change over time, because the more often it is remembered, the more often it is re-encoded, which gives more of a chance of has more of a chance of being altered. misinformation effect occurs when a memory has been corrupted by misleading information. An example of this is people were shown a car accident, a short traffic accident, and then they answered questions about what they had seen. Those asked about how fast were the cars going when they smashed into each other gave higher speed estimates than those asked about how fast were the cars going when they hit each other. About a week later, when asked whether they recalled seeing any broken glass, people who had heard smashed in the leading question the week before were more than twice as likely to report seeing glass fragments, when in fact the film showed no broken glass. So in many follow-up experiences around the world, they have let me restart. In follow-up experiments, they found that this was happening around the world, despite what was actually going on, and so this is where the misinformation effect happened. So exposure to subtly misleading information, we tend to misremember. Just hearing even a vivid retelling of an event may implant false memories. Even repeatedly imagining fake actions and events can create false memories. And so as we imagine things repeatedly, it can be encoded as a memory. I have to sneeze. Excuse me. So the bottom line is, don't believe everything you remember because of the misinformation effect, reconsolidation, and the imagination effect. So there's also what is called source amnesia. Source amnesia is faulty memory for how, when, or where information was learned or imagined. So it's when you retain the memory of the event, but not of its context. Source amnesia, along with the misinformation effect, is at the heart of many false memories. Authors, songwriters, and comedians sometimes suffer from it. They think an idea came from their own creative imagination, when in fact they are unintentionally plagiarizing something they earlier read or heard. So source amnesia also affects, or also helps explain déjà vu. Déjà vu is French for already seen, and it is the eerie experience, or the eerie sense that I've experienced this before. And it's when cues from current situations may unconsciously trigger retrieval of an earlier experience. The key to déjà vu seems that we are familiar with a stimulus or one like it, but can't recall where we ran into it before. Normally we experience a feeling of familiarity before we consciously remember details. We often misremember information. And it's from repeated either misinformation being given to us, it's from source amnesia where can't remember where we learned the information, or it could be from reconsolidation where we've just remembered something so many times that our memory has been altered. So how can we recognize false memories? We can do this, or before I say that, false memories are contagious. When we hear others falsely remember events, we tend to make the same memory mistakes. And this can happen in eyewitness identification and testimony. So I'm trying to find in my notes where I wrote about this slide, and apparently I can't. So when we hear others remembering events that are incorrect, we tend to make the same memory mistakes as them. And this can sometimes lead to problems with eyewitness identification and testimony. So it is more commonly known now that eyewitness identification and testimony is not as accurate as they once thought they were. Of 362 people who were later proven not guilty by DNA testing, 70% had been convicted because of faulty eyewitness identification. And so these false memories and hearing other people remember them can cause us to remember something incorrectly. Hypnotically refreshed memories of crimes often contain similar errors. If a hypnotist asks leading questions, witnesses may weave that false information into their memory or event. So if they ask the leading question, did you hear loud noises? Then they are more likely to weave loud noises into their memory of their event. Memory construction errors also seem to be at work in many recovered memories of childhood abuse. But that is also can stem from leading questions and hypnotically refreshed memories. And so repressed memories. So can memories of childhood sexual abuse be repressed and then recovered? When this happens, there are two possibilities to it. Either people will doubt the childhood sexual abuse survivors who tell their secret, or innocent people are falsely accused. These are the two possible tragedies of when this happens. So can they be repressed? Yes, they can be oppressed. However, trauma usually leads to vivid, persistent, haunting memories and not the repression of memories. You're going to talk more about this when you talk in chapter 12, so I'm going to kind of leave it there. So if we can't really trust eyewitness recall of adults, can we trust eyewitness recall of children? And this is especially true when children are reporting child abuse. And so the problem when it comes to eyewitness recall is that often suggestive interviewing techniques are used like with leading questions, or they are given several examples, and if what happened to them wasn't in those examples, they may just pick one of them, that sort of thing. However, children can be accurate eyewitnesses, and they can do this, and we can obtain effective eyewitness testimony by following certain guidelines. If it is a neutral person that is interviewing the child, and they're asking non-leading questions soon after the event occurred, and using words the child can understand, effective or accurate eyewitness recall can be obtained. However, oftentimes the interviewers are so focused on finding out what the awful things that may have happened that they are, the kids are, feel pressured to providing the information that they think the adult wants. So, yes, we can get children accurate child eyewitness recall, but we have to do it in a non-leading way. So what can you do to improve your memory? There are a lot of suggestions, so I'm just going to go through them real quickly, make sure you understand how you can do this, and then we'll be done. So one of the things you can do is rehearse repeatedly to master material. Remember the spacing effect, use disturbed practice, give yourself separate study sessions, stuff like that. Make the material meaningful, apply it to your everyday life, come up with personal examples, that sort of thing. Activate retrieval cues. Remember the importance of context-dependent and state-dependent memory. Mentally recreate the situation in which you the original learning occurred. Imagine returning to the same location and being in the same mood. This can help jog your memory. Use mnemonic devices. Either create your own or use ones that have been already made. Minimize proactive and retroactive interference. You can do this by studying before sleeping, not scheduling back-to-back study times for topics that are likely to interfere with each other, such as Spanish and French. Sleep more. During sleep, the brain reorganizes and consolidates information for long-term memory, so sleep deprivation disrupts this process. Really important reason why getting good night's sleep before finals is really important. You shouldn't cram all night. And then test your knowledge, both to rehearse it and to find out what you don't know yet. You can do this by testing yourself, because this will tell you both what you know and what you don't know yet, so you can study that more. So hopefully those tips can help you as finals approaches next week. That is the end of chapter 7. If you have any questions on the material, go ahead and send me an email and I can explain it the best I can. Please come to class on Wednesday with any questions on the material. We're going to go over this, the study guide and all that stuff. Other than that, I will see you guys on Wednesday.